For this lesson on predicting the products, you're going to need your periodic table and your polyatomic ions sheet because in order to predict the product, you're putting elements together and you just can't put two elements together. So you're going to have to make sure you put them according to their charges. So these are ionic. So if you don't have those handy right now, if you'll pause the video and make sure you have those. Now, before I get into predicting the product, I did want to include this little side note about a catalyst. Now, you've already have heard about a catalyst in biology. We know a catalyst will speed up a chemical reaction. But I wanted you to see this. This is hydrogen peroxide, and we can break down hydrogen peroxide by adding yeast to it. And when that happens, you get water and oxygen. Now, yeast will speed up the reaction. So anytime you have a catalyst involved in a chemical reaction, you're going to see the catalyst written above the arrow. Now, it's not going to, as far as change the outcome of your product, it's still going to occur. Hydrogen peroxide breaks down on its own over time. That's why it's in a dark bottle, so that because light can also break it down. So yeast is a catalyst that will speed up that reaction. So again, hydrogen peroxide will break down into water and oxygen eventually, but at a slower pace. So just note that a catalyst is a substance that will speed up a reaction, but is not used up in the reaction. So it's neither a reactant nor a product. And like I have it here, it's usually written above the arrow. So a catalyst is just there to, in case you need to speed up your reaction. All right, so moving on to predicting our products. So we're going to look first at a synthesis reaction. So you have learned about the 5 types of chemical reactions. So now we're going to use that knowledge in order to predict our product. So we know in a synthesis reaction, you're going to put your products together. So that's what we're going to do. So you see we have magnesium and oxygen. So I'm going to put these two, because synthesis means putting together, CMG and O. Now, notice I'm not bringing the 2 over. Just because the 2 is there does not mean it's going to be here. Now, what we do have to make sure is if I put Mg and O together, is this the right formula? Well, we got to get out our charges. So look at your periodic table. Note that magnesium is in group 2, so it has a positive 2 charge. Oxygen is in group 16, and it has a negative 2. So if you were to put those two together, you would make sure your charges are equal, and they already are equal. So this is the correct formula, MgO. So if you look, we need to then make sure it's balanced. So you have 2 oxygens here and only 1 here. So we would have to add a coefficient. So now we have 2 oxygens, but we also have 2 magnesiums. So then we need to add our 2 there. So knowing that a synthesis reaction means putting together, we will always put our the product side together. So now let's look at sodium and chlorine. So synthesis, so we're going to put them together. So we're going to put Na and Cl. Now we need to make sure if this is the right formula, and I'm going to write it up here because let's go down here. So sodium is +1 because it's in group 1. Chlorine is in group 17, so it's -1. So that is the right formula. So now we need a balance. So there's 2 chlorines, only 1. So we put a 2 here, and then that makes us need a 2 for the sodium. So that's all you have to do for synthesis. So now let's look at a decomposition. So in a decomposition, we're going to break it apart. So you have HGO. So now let's break the HG and the O. And by breaking it, we're going to put it a plus sign in between. Now, if you remember, is oxygen ever written as just O? And your answer is no. It always is written with a 2 after it. So remember, oxygen is a diatomic molecule, so you have to put a 2, a subscript 2. Remember, there's 7 of them. Now, after we have broken up the Hg and the O, we have Hg plus O2. So again, we got to balance it. We have 2 oxygens here. So if I put a 2 here, now I have 2 oxygens on the left. Let me get that out of the way. And get that. And so we have 2 oxygens on the left, 2 oxygens on the right. Now we have 2 mercuries, 2 mercuries. We have to put it there. All right, if you want to pause the video and do this one. So now we're going to split the Ca and the Cl. And again, Cl is one of those 7 diatomics, so I've got to put a 2 there. Now, this 2 is not there because it was over here. It is there because it's a diatomic. And then to balance this equation, well, everything's balanced. So you can see 1 Ca, 1 Ca, 2 Cls, 2 Cls. So we didn't need any coefficients. So that's all you have to do for a decomposition. All right, single displacement is a little bit more involved. So remember, in a single displacement, one element, here's our one element, is going to replace an element in a compound. Now, normally we only are going to be working with positive ones, but always remember you can always only replace positive with a positive or a negative with a negative. So in this case, and what I'm going to do is let's go ahead and put the charges above on the left side. So Fe, we don't know. Remember, Fe is one of those that has more than one oxidation numbers, but I can figure out what Fe is because oxygen is -2. This is the right formula. So if oxygen is -2, then that means iron is +2. Now, with the lead, what we'll have to do is I would tell you that it is also +2. Okay. All right. So now we're going to put these two, or we're going to swap out our positives with our negatives. So you see Pb is +2 and Fe is +2. So those are the two that will swap. So now the Pb is going to be with the O and the Fe is going to be by itself. Now, Fe is not one of the 7 diatomics, right? So it wouldn't have a 2 after it. So now we look, and because all of these are 2s, these are the correct formulas. And then you would balance this out, and it's already balanced. All right, let's look at this next one. So silver is in group 11, but you should have the charge of silver on your periodic table, which is +1. Now look at your polyatomic sheet for nitrate, NO3, it's -1. And then look at aluminum on your periodic table, and you should see that it is +3. So the two that's going to be swapping are your 2 positives. So here and here. So, so now let's swap that out. So now aluminum is going to be with the Al and with the NO3, and then the Ag is going to be by itself. Now, we have to make sure, now that we put aluminum with the nitrate, we got to make sure it's the correct formula. So remember, Al is +3, nitrate, though, is -1. So we're going to need 3 nitrates. So that means we need to put it in parentheses with a 3. So that's the correct formula. So that's the big thing about predicting your products. Once you put them together, you have to make sure that you have the correct formula. So now we need to balance. So if you notice, there are 3 NO3s on this side, but 1 NO3 on this side. So the only way you can balance it, and let me move some of this stuff out of the way so you don't get all confused at our charges. So to make this one have 3, we got to put a coefficient 3. But that also changes our silver to 3, so we need to put a 3 over here. And so that is our balanced equation. All right, if you'd like to pause the video and see if you can rearrange this one. So again, we're going to look. We don't know what mercury's charge is because mercury can have more than one charge. So I'm going to look at the oxygen, which is -2. Well, if oxygen is -2, then that means mercury is +2. And then sodium is +1. So since sodium is positive, it wants to swap with the mercury. So now sodium is going to be with the oxygen plus now the Hg is by itself. Now, because we've now put 2 new elements together, we got to make sure that they are equal in charges. So remember, sodium is +1, oxygen is -2. So we can swap and drop. The 2 goes to the sodium and the 1 goes to the oxygen. So your formula is actually Na2O. So let's get rid of the charges. So once you get your correct formulas, then you want to balance it. So as you can see, we have 1 Na here, we have 2 on this side. So I'm going to put a 2 there. And now our sodiums are good. We have 1 oxygen, 1 silver, or excuse me, 1 mercury and 1 mercury. So there you have a balanced equation. So let's say, well, I'll save it for next. Let's go on to double. Now, when we're talking about a double displacement, if you remember the definition, or if you look at your definition of a double displacement, the positive ion of one compound replaces the other positive ion in the other compound. So remember this little structure that I gave you in class on your notes. So AB plus CD yields AD plus CB. So you're swapping out. So what's going to happen is this calcium is going to, hang on. This calcium will swap out with the silver. So they're going to switch places. The positive will switch with another positive. So you have to use your periodic table and your polyatomic ion sheet. That's what PTOE, periodic table of elements. So let's see how this works. So let's get our charges. That's always important to go ahead and knock that out. So, and hopefully you remember how to get those charges. So sodium is in group 1, so it's +1. Look on your polyatomic sheet. Hydroxide is -1, so that's why it's NaOH. Potassium is +1, and nitrate is -1, and that's why it's KNO3. So what we're going to do to set this up, I'm going to draw a line because I'm going to put a new positive there, and then put my OH plus, let me move this out of the way, plus another line with my negative. So remember, the K is going to swap out with the Na. So now the K is going to be here, and the Na is going to be here. So that's all you're going to do. You're swapping out your two positives. So the positive that was with the NO3 is now with the OH. So the Na is now with the K or with the NO3. Now we have to make sure it's balanced, and we really didn't change anything as far as adding subscripts to make the formulas correct because all of these were ones. So that would be your balanced equation as well. So if you want to stop the video and try this one on your own. So again, we're going to swap our two positives. Ca is going to swap with the Mg. But let's get our charges. So calcium is positive 2 because it's in group 2. Now, if you look on your polyatomic, SO4 sulfate is negative 2, and that's why it's CaSO4. Magnesium is in group 2, and it's positive 2. OH, on the other hand, is negative 1. So you need two OHs to equal out the positive 2. So now, draw your line and put your SO4. Plus, draw your line and put your OH. So what I'm doing is I'm just rewriting the negative side because I'm going to put the new positive. So we're going to swap. The Mg now is where the Ca was. So we put MgSO4, and now the Ca is now with the OH. So all I did is I moved the Mg to over where the Ca is, and the Ca is with the Mg. So we kept our SO4 and our OH in the same spot. So now we got to make sure there are equal in charges. So remember, Mg is positive 2, and SO4 was negative 2. So that's the right formula. And then calcium is positive 2, but your OH is negative 1. So we need to swap and drop. So OH is a polyatomic. Because we're going to have two of them, we have to put that 2 there. So now you have your predicted product side. So now we need to make sure we have a balanced equation. So Mg is 1 here. There's 1. 1 SO4, 1 SO4, 1 Ca, 1 Ca, 2 OHs, 2 OHs. So we did not have to add any coefficients. So now let's go on to combustion. So if you remember when we were talking about the types of chemical reactions, in a combustion reaction, you always have a hydrocarbon plus an oxygen to yield your CO2 plus your H2O. You have to just remember that. You have to know that your CO2 and the H2O always goes on the product side. And it doesn't matter what order, you can put the H2O first and then the CO2. So then your next step would be to balance this equation. So we have 4 hydrogens here, but only 2 here. So I'm going to put a 2 there to make 4 hydrogens. I have 2 oxygens here plus 2 here. So that's a total of 4 on the right. And so I need to put a 2 there. So that's your balanced equation. So those are your 5 types of reactions in predicting their products. So what I'm going to do next is I have a list of these. These are 5, and I didn't put them in the same order. So if you want to stop the video and then work these out and then see if you get the right answer. All right, so we've got Li plus Cl2. Well, the only thing that we can do is to put it together. So we're going to do that. So LiCl. Now, if you remember, we don't bring this 2 over just because it's on the left side. But what we have to do is to make sure we have the correct formula. Well, lithium is +1 and chlorine is -1. So this is the right formula. So we do not need a subscript of 2. But we do need to balance it because there are 2 Cl's and only 1 Cl. So we're going to put our coefficient 2 there, which then causes your Li to be 2. So we put a 2 there. So that's what you should have gotten for your answer. All right, now we have a compound plus a compound. It's really not a way to put all that together. So probably this is a double displacement. So since it's a double displacement, I'm going to draw my line and put my negative again, plus draw my line and put my negative. So I'm just writing the negatives like they were on this side. So now I'm going to swap the positives with the positive. So now instead of silver being with the NO3, the potassium is going to be there. And now the silver is going to go over here to where the potassium was. All right, so now we have to make sure when we put those new elements together, do we have the right formulas? Well, potassium is +1, nitrate is -1. So you have to look on your polyatomic sheet and your periodic table to make sure you know that. Silver is positive, silver is +1, but phosphate is -3. So that is not the correct formula. Hang on. All right. So now we just swap and drop. So we're going to put the 3 there. And then we have a balanced formula now. So that would be your formula, Ag3PO4. So then you got to go and make sure you're balanced. So there's 1 potassium on this side, and there's 3 on this side. So we're going to put 3 there. Now that makes 3 NO3s. With that coefficient 3 in front, there are 3 NO3s. So we need to do the same thing for this side. So I'm going to put a 3 there. Well, that changes my Ag to also a 3. Well, let's look over here. And we have 3 Ags. We have 1 PO4, 1 PO4. So that is your balanced equation. You don't need any coefficient for this one. All right, this one, as you can see, the only really thing we could do is to break it down. So that's what we're going to do. So this is a decomposition. So H, and remember, hydrogen is one of those 7 diatomics, so it requires a 2. It is not because the 2 is here, it's because when hydrogen is by itself, it's always acts as a diatomic molecule. Plus oxygen, and oxygen is also one of your diatomics, so we got to put a 2 there. Now, so that's why it's important to know those 7 diatomics. So if we look, we have, to make sure it's balanced, and our oxygen, we have 2 here and only 1 here. So that means we've got to put a 2 to make 2 oxygens. Well, then that changes our hydrogen to a 4. So that means we put a 2 here. Okay. All right. And then we have this reaction. If you notice, we have a carbon and a hydrogen. So this is a hydrocarbon plus an oxygen. So this is a combustion reaction. So always it will equal a carbon dioxide plus water. Okay, and you can balance this out on your own. And if you need the answer, you can see it in class when you come. And then this last one, as you can see, we have 1 element and a compound. So that means it's a single displacement. So we're going to swap the Fe with the Pb. So that means, and I would tell you that this is a +2 charge. I would let you know what this iron is because it's not combined. But for lead, because it's with the SO4, SO4 is -2, the Pb is +2 because there's only one lead and one SO4, so their charges are the same. All right, so now we're going to swap them. So now the Pb is going to be by itself, plus the Fe now is with the SO4, and again, +2 to -2, so that is the right formula. And again, make sure this is balanced, and in this case it is. So that's how you do your predicting, and you do have a worksheet to complete and give you some more practice.